So yesterday we talked about synthetic division, and synthetic division is awesome, right? It works great, except when it doesn't, right? Okay? So, like, one of the problems, if I gave you, like, x cubed minus 2x squared minus 3x plus 1, and we divide this by x minus 4, can we do this with synthetic division?
Yeah.
Yeah, of course we can, right? We do our little, with the 4 in the box, and then it's, you put 1, -2, -3, and a 1. Bring the 1 down, this times this is 4, that gives us 2, that gives us 8. Sometimes this gives you 20, we get a remainder of 21, and so then we get our answer as x squared plus 2x plus 5 plus 21 over x minus 4, and we're done, right? Okay, but what if it was, you know, x cubed minus 2x squared minus 3x plus 1 divided by x squared minus 3x plus 4, right? What if it was this? Could we do synthetic division at this point? No, right? Synthetic division doesn't work here, right? Synthetic division only works if you've got like a nice basic term in the bottom, right? So, here, we did one like this yesterday, so do one today. So everybody do that one. Part, well, let's see, this gives us x squared minus 3x plus 4 in that part. And then over here I end up with x cubed minus 2x squared minus 3x plus 1. And so now we think what goes here so that this times this exactly equals that part. And, well, we have an x, so this times this is going to give me x cubed, this times this gives me a minus 3x squared plus 4x. Now we change the sign, so we subtract, so that's a minus, plus, and that's a minus. This cancels because it's supposed to. And this is going to give me x squared minus 7x plus 1. And then you think, what goes here so that this times this is equal to x squared? Guess what goes there? A 1, right? Because we still need something here. So I put a plus 1, so 1 times this gives me x squared. This times this gives me minus 3x. This times this gives me a plus 4. Now when I change the sign, so this is minus, this is plus, and that's minus, so that cancels. It's going to give me a negative 4x minus 3. And this is a little different than the one I did yesterday, in that, believe it or not, this is your remainder, right? The reason this is your remainder is you ask yourself, you know, what do I put here so that this times this is equal to an x? Like, I guess you could force the issue and make it like where you're dividing, right? Because there's no way that you don't multiply by like a polynomial and get, well, something times x squared and get an x. Like, you can't take away an exponent. And the other way you can kind of think about it is, I look at this, I see this as like going back to long division is basically what we did in elementary school. So, you know, I look at this as a 3-digit number, right? It's got 3 spots. I also look at this as a 2-digit number, right? And when you did long division in elementary school, when you're dividing by a 3-digit number and you had a 2-digit number left over, that was your remainder, right? Because this was smaller than this. And since this is smaller than this, right, this is your remainder. So what's my remainder? I'm going to put plus, I'll put the negative 4x minus 3 all over x squared minus 3x plus 4. See how to handle the remainder, right? Sometimes your remainder is 2 terms, not just 1, right? Okay. So, what if, just kind of curious, what if I give you x squared minus 4 and divide that into x cubed minus 5x squared plus 3x minus 4. what's different about this problem as compared to this one? Or are they different? Yeah.
The x, it goes x squared and then minus 4. It doesn't go like down.
It doesn't go in order, right? It's
Yeah.
missing something,
Yeah.
right? Or you feel like it's missing something. Well, technically, it's not missing anything, right? See, technically, this is x squared plus 0x, isn't it? Have I changed the problem any? If I add a 0 times x, I haven't changed the question at all, have I? But by me putting that 0x, I've made it look like something we're comfortable with, haven't we? Right? And so now I can approach this. Think, well, okay, what goes here, this times this is going to give me x cubed, so that's an x, so I end up with x cubed plus 0x squared minus 4x. Change all the signs. So this cancels because it's supposed to. That's going to give me a minus 5x squared plus 7x minus 4. And then I think what goes here so that this times this exactly equals negative 5x squared. It's going to be negative 5x, negative 5. And so now it gives me negative 5x squared plus that 0x plus 20. This first term cancels because I wanted to, and so now I end up with 7x plus 16. There's your remainder. And since we've got a remainder, I want to put plus 7x plus 16 over x squared minus 4. Because we still take, this is our remainder, right? And I still put it over this thing. Does that make sense? Right? Now, yesterday, I'm going to find, where did I put them? 3 left over from yesterday. Oh, there it is. So, yesterday I gave you a bunch of problems where I said, like the first one I said use long division. Like I gave you 3 problems where I said use long division, and then at the end, I said, use synthetic division, and all the synthetic division problems were pretty easy, or very straightforward. I want to address one of the problems that I made you do long division with, and that was problem 9. So problem 9 was this thing. It was 36x to the 4th plus 83x cubed plus 47x squared minus 3x minus 32. All of that. And they're saying divide this whole thing by 4x plus 7. All right. So, could we do this with synthetic division? Yeah, right? It is possible to do this with synthetic division, right? And we take our coefficients, put a negative 7 over 4 on the front. Do you want to? It's kind of ugly, isn't it? Right? So this is one of these cases where, like the 2 previous examples, you couldn't use synthetic division, right? This one you could use synthetic division, but to be honest, I would rather do long division for this thing, right? And I did say you would never have to deal with fractions. You wouldn't have to deal with fractions much when you do the synthetic division. But honestly, if I had a choice, I'd rather not deal with them at all. So just because this it looks like it's an option, you could do synthetic division, I'd almost recommend you not do it. There's a lot of things you have to fix by doing that. And so I would definitely avoid using synthetic division on this one. I would just do long division. I know the act of doing synthetic division seems a lot easier, but not for this one. So that's why I was bringing that up. All right. And unfortunately, basically today is kind of a wrap. I think mentally I've called this harder version of division. But I want to make sure you can how do you do division when you can't do synthetic? Like, how do you handle it, when there's a quadratic or something on the outside? And the only way I think you do this is you practice. So,